So midpoint and distance in the coordinate plane, section 1.6, last section of the chapter. All right, vocabulary here. The coordinate plane. The coordinate plane is a plane that is divided into four regions or four quadrants by a horizontal line called the x-axis. So there's our x-axis. And a vertical line called the y-axis. There's our y-axis. Little review. Who remembers what the quadrants are? Who remembers? Trevor?
Top right is 1.
1?
Left 2. Down 3. Right.
Nice job. They go in counterclockwise direction, going from top right all the way down bottom right. Okay, yeah, those are the four quadrants. Good review. A leg. Now, we are going to talk about the distance formula. You can use these formulas. I will show you all the different ways you can use the formulas. Or if you have an understanding of what they come from, you can use different ways to solve this. One of them would be the Pythagorean theorem. Okay, to use distance formula, you can use Pythagorean theorem. In order to know Pythagorean theorem, you have to know legs, though. A leg is one of the two sides of the right triangle that form the right angle. So if I have a right triangle here, okay, the legs are what form that right angle. Typically, it's the two shortest sides, really, in a right triangle. Okay, so it's the legs are what forms the right angle. Whereas the hypotenuse is the side opposite of the right angle. Hypotenuse is also the longest side in a right triangle. Okay, hypotenuse is the longest side opposite of the right angle. Okay, who can tell me what the Pythagorean theorem is? Who remembers? Troy? Very good. A squared plus B squared equals C squared, where A and B are the legs and C is the hypotenuse. Okay? A and B are the legs, C is the hypotenuse there. When we get to the distance formula, this is one of the ways you can work. If you're more a person that visualize, that might be probably a better method for you if you like the coordinate plane and like to visually see it. Pythagorean theorem is a lot better. If you're a person that, hey, I like to use formulas and plug information and work it all out, then you can use the distance formula. All right, I'm going to show you a lot of different ways to do these different parts. Okay. All right, next here. We're going to talk about the midpoint and distance formulas. The midpoint formula. All right, when we think of midpoint, the midpoint is the what of like a line segment? It's in the middle. So when you think of the midpoint formula, I want you to think of really, it's nothing more than the average. Okay? The average. Or if you want to think of another word as the median. Okay? The midpoint formula is nothing more than if I gave you two numbers and I said, hey, find the average of these two numbers. If I gave you two numbers and said, find the median of these two numbers. That's all you're doing with the midpoint formula. All right? So let's say, Drew, if I give you the numbers 4 and 6, and I said, I want you to find the average of those two numbers, what would you do? You would add them up and divide by 2. Hey, look, that's how you get your x-coordinate. You take the x values, add them up, divide by 2. Let's say I gave you two other numbers. Noah, let's say I gave you the numbers 2 and 6. How would you find the average of those two numbers? Hey, guess what? That's how you get your y value. It's the same exact thing. All right, the midpoint formula is really just saying, I'm going to add my x values, divide by 2, add my y values, and divide by 2. Okay? That's all the formula is saying. It's really just find the average or the middle of those 2 points, the median of those 2 points. All right, distance formula. Now again, a little more confusing. This is really derived from the Pythagorean theorem. With midpoint formula, you're adding. Okay, you're adding your coordinates. The distance formula, now you're going to subtract your coordinates. Okay. Now with subtraction, a lot of people usually get confused here. We are squaring the difference of them, so it doesn't matter if you subtract them and get a positive or a negative, because when I square it, I'm going to get the same answer. For example, if I subtract and get a positive 2, 2 squared is 4. If I subtract and get a negative 2 squared is still 4. Okay, so it doesn't matter which way you really subtract there. Because you are squaring it, you will get the same answer. All right? But again, distance formula looks a little bit more confusing. It is a little bit tougher. Once you get the hang of it, it works. And if you're like looking at that already, you're like, man, that looks way too confusing, I'll show you Pythagorean theorem, and that will work every time just as well. Okay?
Hold on.
All right, so let's look at the midpoint formula here. All right, the midpoint of a line segment separates the segment into two halves. Again, the two halves would be equal. They are congruent. That's what makes it a midpoint. Okay, you can use the midpoint formula to find the midpoint of the segment within the coordinate plane. All right, the biggest thing or the biggest mistake students make when they use the midpoint formula is they mix up the x and y's. Now, in a coordinate or in an ordered pair, what comes first, the x or the y, Caitlin? The x, and it's always like the what? Which comes first, x or y?
X.
Always like the alphabet. Very good. Okay, it's just like the alphabet. The x always comes first. So as I look at my ordered pairs here, I have my x value and I have my x value. I add my x values, 1 plus 7 here, and I write it over 2. And then I add my y values, 2 plus 6, and I write it over 2. I then simplify, 1 plus 7 is 8, 2 plus 6 is 8, still all over 2. I simplify, I get my midpoint of 4, 4. And again, if you look over here, that means my two segments there are congruent. That is where the location of the midpoint is. Okay? So let's look at a couple problems here. Try these out. All right, number 1. I have the coordinates 4, 2, and -2, -1. I want to find the midpoint. Midpoint formula. x1 plus x2 all over 2, comma, y1 plus y2 all over 2. Okay? So as I look at those values, what are my x values? What are my two x values up there, Jack? So I have 4 plus a -2 all over 2. I'm plugging my x values into that formula, comma. What are my y values in those problems, Tyler? So 2 plus a -1 all over 2. And now I just simplify. Well, what's 4 plus -2 gonna get me, Max?
2.
So I have 2 over 2, comma. What's 2 plus -1, Max? Get 1 over 2. Now I just simplify. 2 over 2 really becomes what, Keegan? 1 over 2 really becomes what, Keegan? 0.5, or I could just leave it as a fraction, which is 1/2. Either one is acceptable there. So my midpoint is 1 and 1/2. Again, it's nothing more than you're just finding the average or the median of those 2 points. Add the x values, divide by 2. Add the y values, divide by 2. Again, the biggest mistake students make is they would confuse and put the x with the y. Don't do that. Make sure you distinguish which one are your x's, which ones are your y's. Number 2. Let's try this one here. I have -2, 3, and 5, -3. Well, what are my x values that I'm going to add together? Kendrick, what are the x values in that one? What I say the biggest mistake was going to be? Mixing up the x and the y's, right? I want x values. So I have -2, which is my other x value. Look at the other ordered pair. 5. Okay, it's the first value in the ordered pair. So -2 plus 5 all over 2. And then my second one, what are my y values, Gabe?
3, -3.
So 3 plus -3. And again, all over 2. Now I simplify. -2 plus 5 gets me what? Hannah, what's -2 plus 5? -2 and a +5. If you want to switch it around, you can say 5 minus 2. 3 all over 2. And then what's 3 plus negative 3, Drew? 0 all over 2. Well, now I simplify. What's 3 over 2 simplify to, Jack? 3 over 2 simplify. Thank you. 1/2. What's 0 over 2 simplify to, Jack? 0. My midpoint is 1.5, 0. And recognize my answer is a coordinate. Okay, I'm dealing with coordinates here, so my answer is a coordinate. So I put my answer as an ordered pair. Let's try number 3. What are my x coordinates, Johnny? So -4 plus 6 all over 2, comma. What are my y values, Austin? So 3 plus -2 all over 2. Now I'm going to simplify. -4 plus 6, Nick?
2, positive 2.
Over 2. 3 plus -2, Nick?
Positive 1.
All over 2. And I simplify. What's 2 over 2 going to get me? Camden?
1.
And 1 over 2 is going to get me?
0.5 or half, 1 half.
So my midpoint is 1 and 1/2. Is the midpoint formula really that bad? Do you see how it's just like finding the average or the median? Again, very similar here. Try these 3 on your own now.
What is that? Microphone.
All right, here we go. Answer number 4. What is the midpoint of -4, 7, and 9, -3? Troy, what's my midpoint? Slides changing on me here. All right, there you go. Troy, what's the midpoint?
2.5.
How about if I go 2.5, comma 2? I like that. 0.5 is just acceptable too. I just like fractions. 2.5, 2. Awesome.
Fraction.
Midpoint of number 5. Catherine?
0,
Nice job. 0 and -2. Good work. And the midpoint of number 6 goes to Tina. 1 and 1/2, -4. Nice work. Okay. Again, midpoint, finding the average. Now comes the next part, new part for some of us here. Using the midpoint, I want to find the other endpoint. Okay. Now, there's a couple of different ways to do this. One way is we can do this algebraically using the midpoint formula. I'll be honest, that way is very confusing. It's a lot harder, I think. I think actually understanding what a midpoint is can make this problem less difficult. Okay? So when you think about a midpoint, what do you know? It's right in the middle. So midpoint is, what else would you say? It's equidistant from both endpoints. Would we all agree on that? So if it's 3 units left from the endpoint, it's what, 3 units to the right, right? So I'm going to use that concept to try and solve this. Okay, so number 7. I have AB here. All right, so A and I have B. And I know that M is right in the middle. I'm just going to draw a diagram here, just kind of visualize. Now, I want to find the distance from my X. So my X value, I'm going from 2 to 4 there. What's the difference from 2 to 4? How do I get from 2 to 4? You add 2, right? So I know it has my X value has a distance of 2. So that's like saying I'm going from here to here, plus 2. Well, what do you suppose I'm going to do from M to B then? I add 2 again. So what's 4 plus 2? 6. Hey, I just found my X value. Okay. Why? Because the middle has to be the same distance from my endpoint on the left to my endpoint on the right. I'm going to do the same thing with my Y value. I'm going from 2 to -3. How do you get from 2 to -3? Subtract what?
5.
Subtract 5. Well, I have to do the same thing on the other side because they have to be equidistant. So I'm going to subtract 5 again. -3 minus 5 gets me what, Trevor? Hey, I just found my other endpoint just by knowing the midpoint has to be equidistant from both sides. Okay? Does that make sense how we can use the midpoint to find that? The other way you'd have to do is you have to plug the information into the midpoint formula, multiply by 2, and then subtract, which sounds a lot more difficult and actually is. Okay, so understanding the midpoint can make these problems a little bit less difficult. Let's try the second one here, number 8. M is the midpoint of xy. So same thing here. Here's xy. You know, m's in the middle. I'm looking at my x values. I'm going from 2 to 6. How do you get from 2 to 6, Max? So to find my other endpoint, what am I going to have to do again? Yeah, I'm going to have to add 4 again. Well, 6 plus 4 is 10. Nice work. Now I look at my y values. How do I go from 7 to 1? Troy? So, to go with my next coordinate, what am I going to have to do? Subtract 6. 1 minus 6 is? And I have my other endpoint. Okay? Again, using those values, because you know the midpoint has to be in the middle, equidistant from both sides, I can find that. Try number 9 here on your own, using that same concept. Alright, let's walk through this here. So, -6 to -1. What am I doing there, Max? -6 to -1, I am? Adding 5. So I add 5 again, and I get what for my x value, Max? 4. Alright, let's look at the y value here. I'm going from -1 to 1. What am I doing there, Noah? Adding 2. So I add 2 again. 1 plus 2 gets me what, Noah? 3. Hey, my other endpoint is 4, 3. And again, I find that because I know the midpoint is equidistant, so the same distance on either side. Alright? Next, I'm going to find the distance here. Alright? So using the distance formula, again, I'll try one showing you how to use the distance formula, then I will show you how to use Pythagorean theorem as well. Okay? So the distance formula can be used to find the distance, d, between points A and B in the coordinate plane. Okay? The biggest thing you have to remember here is take your x values together, take your y values together. You're going to subtract them. Okay? Subtract them. And then you square the terms. Okay? So you get the square root of 36 plus 16. Simplify from there. The square root of 52. Square root of 52. We'll use a calculator to round most of our answers to either the nearest tenth or nearest hundredth. So that's okay. And you get approximately, okay, that approximate symbol, 7.2. Now, if all that looks way too confusing to you, you're like, man, I don't know about all that. Well, I can see up there, I want to find this distance from A to B. Another way to do that is to draw in a right triangle. Say, I can make in my right triangle. Now I can visually look at my legs. Well, this distance here, I'm going to say A is 1, 2, 3, 4. That has a distance of 4. The top side there, I'll call that B. C is always the hypotenuse. Okay, it has a distance of 1, 2, 3, 4, 5, 6. That has a distance of 6. I can now use Pythagorean theorem. A squared plus B squared equals C squared. Okay, so I take 4 squared plus 6 squared. Set that equal to C squared. 4 squared is really just 16. 6 squared is really just, so 16 plus 36 equals C squared. 16 plus 36 is nothing more than 52. And the last step, always in Pythagorean theorem, is to always take the square root, which, hey, look at that. Square root of 52, square root of 52. Either way, I get approximately 7.2. Okay? So So again, if you're looking at this, you're like, that formula looks way too confusing. I can't do that formula. Use a coordinate plane, plot the points, make a right triangle, and then you can actually count the distance and still get the right answer. Okay, so again, a lot of you who might be more of a visual person that have to see it, that'd be what I would probably suggest. Yes, sir.
With using the calculator like to round the nearest 10, can we leave it as a square root instead?
Depends what it asks for. If it asks for the square root, you can leave it as that, but otherwise, use the calculator. No. All right, so number 10 here. I'm going to first do number 10 using the distance formula. Okay? If you don't want to use the distance formula and you want to try Pythagorean theorem, make a coordinate plane so you can get ready for that. But number 10 here, distance formula. All right, D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Long formula, I know. Okay, but really one of those things, once you get the hang of it, it's not too bad. So I'm going to plug in my x values here first. So I get D to equal the square root of negative 2 minus 2 squared. I plugged in those x values plus 3 minus a negative 2 squared. Again, really it's just the difference of your x's squared, the difference of your y's squared. That's really where that comes from. Well, negative 2 minus 2 is really just negative 4 squared plus, I have 3 minus a negative 2. Two negatives get us a positive. 3 plus 2 is really just 5 squared. So now I have negative 4 squared is 16. 5 squared is, hey, look at that. Both comes out to be positive. Like we talked about, whenever we square something, it comes out positive. 16 plus 25 is then 41. And then our last step, always our last step here, is going to be finding the square root. The square root of 41 is what, Peyton? I think I see you have it.
6.4.
Approximately 6.4.
Can I use a calculator on my phone?
For now, it's fine.
For right now?
Okay. Now, if all that was like, whoo, that's a lot of work using all the formula, I don't know. I'm going to show you how to do the same exact problem with a coordinate plane. Okay. So let's look at a coordinate plane here. Now, I'm drawing one on here, so it's going to be a little bit tough to see maybe.
Draw that all by
I did.
yourself?
Looks good. So negative 2, 3. I plot negative 2, 3. It's about right there. 2, negative 2. 2, negative 2 is about right there. Okay? I want to find this distance from point A to point B there. That's the distance I'm trying to find, which we already found was 6.4 using distance formula. Not using the distance formula, I make my right triangle now. And now I can visibly count my side lengths. I have a distance of 1, 2, 3, 4, 5. This one has a distance of 5. The bottom has a distance of 1, 2, 3, 4. Okay. I find my distance there. Using Pythagorean theorem, I plug my legs in. So 4 squared plus 5 squared equals c squared. 4 squared is really just, 5 squared is really just 16 plus 25 is, I get 41 equals c squared. And then our last step, no matter what we're doing, is always find the square root. Square root of 41 is, well, we already found it, still 6.4. Okay? So if you think you're going to struggle with that subtraction of everything, hey, plot the points out, put the right triangle in, and use Pythagorean theorem. Okay? Let's try number 11 here. I'm going to have to erase so I can see the rest of my problems, so I can have some room to work these out. It's easier to erase my finger there. There we go. All right, so number 11, distance formula. Still using that up there. What are my x values here, Caitlin? So I'm going to plug that in. I have the square root of 3 minus negative 3 squared plus, what are my y values, Jack?
Y value. 1 times 12.
2 minus a negative 1 squared. Well, 3 minus a negative 3 is really just, so I get 6 squared plus 2 minus a negative 1 is really just 2 plus 1, giving me 3 squared.
36.
6 squared is what, Camden?
36.
3 squared is what, Camden? 36 plus 9 is what, Camden?
25. Oh, sorry, 45.
And again, our last step is always taking that square root. The square root of 45, let's go to 1 decimal here. Square root of 45 to the nearest 10th. Tom, you got it?
6.7.
Approximately 6.7. Awesome. And again, if you use Pythagorean theorem, you would have found lengths of 6 and 3 for your legs. And you would take the same thing, 6 plus 6 squared, 3 squared, again 36 and 9. Add those together, you get 45. And the last step would still be the square root of 45. Okay, and you can kind of see when you subtract, that's how you find those distances, really.
Wait, I thought you just subtracted the distance.
You do. But when you're subtracting a negative, you get a positive.
Oh, yeah.
Right?
Yeah.
All right, let's try number 12 here. What are my x values? Yes, sir.
So like on task we can use either distance.
You can use either distance formula or Pythagorean theorem. Yep. Nope.
Okay.
You can use either one, whatever works best for you. Just say find the distance between these 2 points. Whatever you can find works. Okay, number 12 here. Negative 2 and negative 2, 4 and 3. What are my x values in that problem? Hannah, what are the x values? So negative 2 minus 4 squared plus, what are my y values, Troy? Negative 2 minus 3 squared. Okay, what's negative 2 minus 4 going to get me, Camden?
-6.
So I get negative 6 squared plus negative 2 minus 3 is what, Jack? Negative 5 squared. Now, negative 6 squared is really just 36. Negative 5 squared is really just 25. 36 plus 25 comes out to be what, Trevor?
61.
The square root of 61, which then approximately what? Trevor, do you have it? 7 point what? 7.8. Nice job.
Use a calculator.
Okay, if you use Pythagorean theorem, instead of negatives there, you get a distance of 6 and 5, which still comes out to 36 and 25, which is where we get the same answer. Okay? Now, we are running out of time. We will finish this up tomorrow, but for those of you who are not here, I will give you your assignment now.